Atomic hydrogen welding. It is a welding process wherein fusion is produced by heating the job with an electric arc maintained between two tungsten electrodes in an atmosphere of hydrogen, which also acts as a shielding gas. Filler rod and pressure may or may not be applied depending upon the condition. Principle. It possesses the features of both arc and flame welding processes. The job does not form a part of the electric circuit. Combined energy of the arc and a chemical reaction is utilized for welding. Electric arc is struck between two tungsten electrodes. This arc supplies energy for a chemical reaction. Chemical reaction. The molecular hydrogen passes through the electric arc and it dissolves into atomic hydrogen by absorbing the energy supplied by the electric arc. H2 gets decomposed into H plus H 100-700 calories. The atomic hydrogen thus formed is unstable and has a tendency to revert back to molecular state. This recombination takes place as the atomic hydrogen touches a relatively cold workpiece to be welded. The recombination is an exothermic reaction which liberates large amount of heat, approximately 3730 degrees Celsius. This heat combined with that of the arc is utilized for welding process. Because of very high heat conductivity of hydrogen at elevated temperatures, the heat is delivered to workpiece at very fast rates. Equipment: welding torch with tungsten electrodes and cable, hydrogen gas supply, AC power source, a transformer with an open circuit voltage of about 300 volts. Figure shows the detail. Workpiece, filler metal, hydrogen, tungsten electrode, torch, hydrogen shielding, fan shaped arc, weld bead and 300 volts AC supply. Operation: hydrogen gas supply is made and current is switched on. The arc is struck by bringing the two tungsten electrodes in touch with each other momentarily and then separating them by a predetermined distance, say 1.5 meter. Depending upon the thickness of the job to be welded, a current value can be set. The atomic hydrogen welding arc is held over the job till a molten pool forms. The welding torch is carried along the surface to be welded with the arc edge touching the surface. Hydrogen creates a reducing atmosphere and avoids weld metal contamination. Depending upon job thickness, filler metal may or may not be added. For welding, a mild steel plate of 10 mm thickness, about 60 amps of arc current is required. Advantages: no flux or separate shielding gas is used. Hydrogen itself acts as a shielding gas and avoids metal oxidation. The job does not form a part of the electrical circuit. The arc remains between two tungsten electrodes and can be moved to other places easily without getting extinguished. Welding of thin materials is also possible, which otherwise may not be successfully carried out by metallic arc welding. Due to high concentration of heat, welding can be carried out at faster rates and with less distortion of workpiece. Disadvantages: the process cannot be used for depositing large quantities of metals. Welding speed is less as compared to that of metallic arc or MIG welding. The process becomes uneconomical for certain applications because of higher operating cost as compared to that of other welding processes. Application: the process can be used for the welding of most of the metals and alloys like plain carbon steel, alloy steel, stainless steel, aluminium, copper, nickel and their alloys.